Hello, Hadi. How you doing?
Hey, Afshin, I'm doing great. How are you?
Good, good. Thank you. Thank you very much for being my guest in this episode of your PhD Genius. I appreciate it.
Yeah, it's my pleasure. I'm happy to uh, be here to talk with you in this about my PhD
Oh,
and
oh, that's awesome. Thank you very much. Hadi, maybe we can, as you may know, so we have started this channel for PhD candidates, PhD students, and PhD graduates to help them navigate through job transition from academia to non-academic positions.
yeah,
And but for people like yourself, for example, who haven't had any industry jobs and you're still in your postdoc or
yeah,
you're still dealing with some like academic projects. So this program is for people like yourself as well. So why
yeah,
not just start by introducing yourself? So where you did your PhD, what was the research topic? Maybe we can start there and then move to your postdoc projects, and I'll ask some other questions. So please,
yeah. Sounds good. Yeah, yeah. So
thank you.
I'm Hadi Afshari. I did my PhD at University of Oklahoma, and my the subject of my PhD was, or subject of our research was, application of space application of the solar cells or solar panels. And what we were doing, we were just bombarding the solar different technologies of the solar cells with high irradiation levels, high energy electrons and high energy protons. And then we were studying the effect of this irradiation on the performance of the solar cells. So we would track how the efficiency changes after uh, irradiation with different energies of electrons or protons. That was the part of one part of it. Another part was, I mean, in general, if I want to say, I would say just the harsh environment of uh, harsh space environment and anything that comes with that. So another big issue at the space conditions is uh, uh, very low and high temperatures. So we would go through this process of, or we would make these solar cells to go through this process of thermal cycling, very starting from very low temperatures, minus 100 degrees Celsius for some specific planets, minus 200 degrees Celsius, up to uh, plus 100 or plus 200 degrees Celsius. So we would go through this thermal cycling, and then we see uh, the effect of this process along with irradiation with protons and electrons, and we combine all of those, and then uh, we would just test to see how the performance changes and what aspects of the performance changes. If it is related to electrons being extracted from the solar cell, then there are some specific solutions for that. If it is related to the energy of electrons that are already extracted, there are two important sides. One of them is if the electron is getting extracted from the solar cell at all, yes or no. So some irradiation effects can reduce the number of electrons that are extracted from the solar cell. So then we can suggest some solutions for that. But another side of these effects are that the electrons are extracted but with much lower energies.
Mhm.
So the potential that, or the voltage that they are creating is lower, although they are extracted from the solar cell. So, so the one thing is that to do a diagnosis test after these going through these harsh uh, procedures, and then we kind of provide some solutions for
Okay,
the
that's
impact. Yeah.
excellent. So, based on your research, so this is for basically this is an application in like space science or things like that, right? So this is not
Yeah.
for yeah. Okay. So do you have any like presentation or things like that that you can
Yeah. So it's part
show?
of my, yeah, I have the first 4 pages of my PhD defense ready.
Yeah,
If I,
sure. So why not just to give the audience some oversight about like what the application looks like and what your research was about
yeah.
based on things that you just explained.
So let me start sharing my screen then. So do you see my screen?
Yes.
Yeah, okay, good then. So
Please
As I
go full
mentioned,
screen. Maybe you can go full screen if you will.
yeah, that's a good idea. Is it better now?
Yes, it's much better.
Yeah, yeah, okay. As I mentioned, I did my a PhD at University of Oklahoma. You see some symbols of which on two sides. So the
Right.
title of my PhD was Space Application of, now it is covered with this, Space Application of Novel Solar Cells. And generally, a space industry is powered by solar energy. So this was just the first page to show some of the, let me get this laser pointer. If I can find it. Oh, I think it is good. Yeah, it's good. I didn't find it in here. Okay. Uh, so where were I? Yeah, so generally, uh, application of the solar cells started at a space. So the first time that they used a solar cells was in a space, and I think it was 1958, or the first satellite sent to a space used solar cells. So the biggest application of the solar cells is for space application. Uh,
Excellent.
yeah. So, so the outline of my PhD defense was looking like this: space industry, an economy or economy that is powered by solar energy. So, three generation of the solar cells that we tested in harsh space environment. Uh, was one of them was 3.5 based on 3.5 semiconductors. The main technology that I worked on was gallium arsenide antimonide solar cells. The second generation was thin film solar cells. Uh, the main technology that I worked on was CIGS, or copper indium gallium diselenide. Those are thin film solar cells. They are flexible, and in that sense, and they are very lighter. In that sense, they are very suitable for space applications, because, as you know, it's very difficult to uh, move heavy solar panels to space on satellites. So
Right.
the lighter they are, it's better. And the other good thing for them is that if they are flexible, they can be folded in shapes that are uh, useful for space applications. And the last generation, no, it's not the last generation of the solar cells, but the third generation of the solar cells that we studied was uh, a hybrid of organic, inorganic solar cells. And the technology that specifically we focused on was perovskite solar cells. And these perovskite material are way more uh, in nature flexible, so they are better hosts for defects. So irradiation has a smaller effect on them, because these systems are already full of defects, and they are functional despite that fact. You know what I mean? Uh, and because of that, they are better hosts for new defects.
Mhm.
In collaboration with another university, we sent a CubeSat to lower Earth orbit, and that way we could uh, test the performance of uh, these perovskite solar cells, not just in our lab, but actually in the orbit of Earth.
Oh, that's awesome.
Yeah, yeah, yeah. That was very good. It was a very big project. Yeah.
Yeah, I didn't expect you would say that actually. I thought that was just like a lab-based research. So it has
No,
been
no, no.
tested in real world.
Yeah, yeah, yeah.
Okay.
So yeah, we sent one CubeSat to space, and we got the data, and we are publishing one paper on the results of that. And we are planning on sending. I mean, there is a second CubeSat that we are working on to be sent to a space, but that's on the way. It's not in the space yet. It's not in the orbit yet.
Okay.
Uh,
Awesome.
yeah. Yeah, I also was very excited when I got to learn that we are doing that. Not just because, when you're testing your samples and your systems in the lab, the feeling is not the same as you get to see them in real application. You know what I mean?
Mhm. Okay, did you have any like collaboration with the industry at the same time? You mentioned the other research group, but was it like related to the industry directly, the end users of this application, or just another
It was,
university?
yes, it was related with the collaboration. So there was not just a university. You know, the CubeSat, the NASA took it to the space. That was one side of it. Another
Right,
side was there was a company based in California, if I'm not, there was a company that was providing us with, for that I need to go to the almost near end of my, if it is, so because, so we used to use a Kitly machine that I know you know of it.
right.
Let me jump into that. Sorry. Yeah, so this was the CubeSat, and these are our solar cells. Let me see. Yeah, so this device, this Kitly, there is a company that makes these AMU units, and this
Yeah.
does the job. You see this guy holding this small kit. This thing does the job of Kitly. And here, what I'm showing in this figure, the data that we took once using a Kitly and once using an AMU. So uh, for this specific part, we had to collaborate with that company that was providing. I forgot the name of the company because you know it was like uh, 3 years ago or something like that. Yeah. So they provided some parts of that for us.
Okay,
And
awesome. So are you hoping to like stay close to your research area, or are you open to adjacent paths as well? So you want to like continue like this postdoc work, or you want to like explore some other opportunities?
yeah,
And
definitely I want to, yeah,
yeah,
definitely I want to explore other opportunities. I mean, uh, I want to go towards the industry. I want to, I'm very application oriented person. I have this mindset of I want to make things to work better, more efficiently, or just make a device or things like that. So yeah, so I'm very motivated, and I'm very pursuant of working towards uh, industry and application of the different types of technologies.
okay, awesome. Thank you. So what has been the biggest challenge for you professionally at this stage? I mean, after graduation from your PhD and you started a postdoc job, actually. So what has been the biggest challenge so far?
So that's a very good question because that's the thing that a lot of students, PhD students, are going to face. And that is in the physics department, you're not very much exposed to the industry. And in that regard, I think engineering departments are doing better since they uh, provide this opportunity for their students to go and work as interns uh, in different types of industries and companies. They give them that opportunity. In the physics department, unfortunately, this condition is uh, not there, and they do not allow students. I mean, it's not that they do not allow. It depends on the projects that you are involved on and things like this. But I think what I'm saying is that it's really very good if, uh, for example, in the physics department also this chance is given to the students so they can do some internships, and in that way they get to know about the company and industry culture and the things that they need in there, and generally get to know that environment better because yes, I think I haven't been yeah,
So
I
industry exposure, basically, that this is something that you think a lot of PhD candidates and postdocs would benefit from if the institutions, universities could provide more industry exposure for those who are seeking jobs outside academia. So basically, your point is more towards that, right?
yeah, definitely, definitely,
Yeah.
yeah, yeah, yeah.
So because you have had some collaborations, so you can stop sharing your screen if you want. So
Yeah, yeah, let me stop sharing. Yeah.
because this was a like a collaborative project. Uh, so we're back. So because
Yeah.
this was a like a collaborative project, so have you found it difficult to translate your academic experience into a language that employers understand or like other industry partners understand? Or you were just talking to the research teams, so that you had that common language between teams. So what was your experience like?
So I think that in that for that one project that I worked with industry, I think that was kind of easy. But if I had the chance to work on more projects in relation with industry, that would have helped me a lot. Yeah, but generally, uh, if I had the chance to work with industry, work on their projects, I mean, go to their company and spend some time in there and see their projects and their problems on the side, that would, I mean, I think that's a very nice way to move towards industry.
So do you yourself feel underprepared in any areas for industry roles? For example, we had this conversation the other day. You said that you're like learning some new software, some new tools,
Yeah.
techniques. Can you tell us more about that experience?
So I had, for example, I used Python for some of the projects that I worked on in PhD. For some data analysis, data fitting, and some to sending some commands to some machines. I use Python, controlling systems. Now I'm expanding on that. I'm trying to work on more projects. So I know that industry uses this software language very much. So I'm trying to do more projects uh, to get more prepared for the
So how do you learn basically? So what's your approach for learning new skills and new tools, techniques that goes beyond what you did previously in your PhD program or in your postdoc? So what's your approach towards learning these things? What are your sources, for example? Do you read books? Do you take online
so
courses?
Coursera. There are a
Go
lot
to-
of, yeah, yeah.
Yeah.
There are a lot of institutes or Coursera, for example, is one of them. The thing, or just on the YouTube, there are a lot of uh, videos related to different types of subjects, including the software, different types of softwares. So Coursera is one of them. Uh, yeah, I mainly use those and some books for example, for Python.
Right, right. So as you may know, so a part of this community that we have initiated for PhDs is skill development, training, mentorship, and
Yeah,
things like that.
yeah.
So how close do you think the tools, techniques, and research skills that you developed during your PhD program or your postdoc project matches or match what the industry needs basically? Are they very similar tools and techniques, or basically you already mentioned you are already learning some new like techniques and tools, programming languages
Yeah.
and stuff like that. So my question is more generic. May sound very generic, but what do we learn in our program, PhD programs, in our postdoc projects, for example? Are these the actual tools and techniques that industry uses as well? Or no, it's like more complex, it's more like more advanced. And the second question is, are those tools and techniques already available to PhDs in academia, or PhDs may not have access to these tools while they are like in their programs, and they gain access to those tools and techniques after academia. So what do you think?
So I think both of them. Let me put it this way. You are correct that some of the techniques that we use,
Mhm.
it's very advanced for the industry. They don't need that.
Mhm.
That is one part of the thing. And another thing is that the things or the techniques and the skills that some of the skills that industry needs, we don't know them. You know what I mean? It's not they are
Mhm.
difficult. but the thing is that we did not spend time to learn them during our PhD programs, for example. So, uh, so that the one part of it is that some of our skills, uh, I mean, I would say it like this: the things that we know, a lot of it, they don't need that skills. You know what I mean? And they need.
Mhm.
It's not that they don't. I would say maybe like 30% of the things that I know, for example, or the machines that I work with, they are interested or they have them, and they said, yeah, that's good. And there are some other things that I need to learn myself through different ways, not just university, through books, through other institutions, through watching courses from other universities and things like this. So there was a course. And I don't know. Uh, mm, there was a course called Automation and Measurement. That, for
Mhm.
example, was a simple course, but it was very practical. And I think engineering, electrical engineering at OU provides that course, which is very practical. And a lot of my friends took that course, and they were very happy with the results. And I mean, it helped, that course helped them to get to the industry positions. So if students, PhD students, find these courses that are more practical, uh, that's going to help them a lot if they are interested to go to a job that is industry related.
Well, that's good advice, but how can they know what tools and techniques they would need in industry while they haven't had any, ex they haven't been exposed to industry during their programs. So what would be your advice? Like, because the problem is that a lot of students wait until they graduate and then they, start to figure out what tools and techniques might be needed for the types of jobs, I mean, non-academic types of jobs that they are
Yeah.
looking for, right? Because they're too busy just, doing the project and, doing their research, writing papers, defending their thesis and going to these conferences and stuff like that, but they keep delaying that process. And that
Yeah.
causes a huge, huge problem. So what are your thoughts on that? So how can they know what kind of tools and techniques they would need? Mm.
So usually people get to know about this about with the help of their senior students and things like this. So that was my problem, right? When I
Mhm,
got to learn about this course, it was already late, and
mhm,
that course was not anymore available to me. You know, I
mhm,
tried to enroll for that course, but they said there is a kind of big line. Everyone wants to take this course, and now you're like in fourth year or fifth year,
mhm.
you're not gonna get the chance to attend.
Too
So
late.
yeah, it was too late.
Mm.
So if they start early in making connections in industry and networking and just talk to people who are working in industry, I think if they start early and talk with them to see, if you can tell me what things are needed or requirements, so what skills and techniques are going to be helpful for me to uh, learn, so they can use those things. Yeah.
Okay, excellent. So another important part of this initiative we have started, basically PhD Genius for this community, is talking about this networking, as you mentioned very precisely. So networking is extremely important for having the opportunity to get to know new people, for example, in industry, so that they can refer you to the right positions or the types of jobs that are suitable for you, basically. And that's largely missing in academia. So we want to provide such an environment for PhDs. But in that regard, so the role of supervisor may be also very important, right? Because some supervisors, PhD supervisors, have direct access to industry. So it's
Yeah.
not just industry, I mean, like manufacturing or like these high-tech companies like Samsung, for example, or like
Yeah.
Meta or, companies alike, but also consulting companies, for example. Some of them may have like access to some other like government organizations, for example. So
Yeah.
what important role do you think this supervisor can play in creating that opportunity, creating that exposure for their PhD students?
Yeah, so I think uh, if the supervisor have good connections with industry, if they are working with industry, they definitely can help in that regard. Uh, for some for some specific fields, for example, theoretical physics, that's not the case usually. Usually, supervisors do not work with industry. They do not need, if you're in applied physics, you get grants from some industries and you get to collaborate with them. But if you're in theory, uh, that's not the case. And yeah, but generally, if the supervisor knows a lot of industries, it has good connections with them, then they can kind of introduce you to them, or they can uh, write good recommendation letters, help with the networking. But that depends on the field that you're studying. That's one thing, and the other thing is that if the supervisor have good connections or not. If they are not
Mhm.
working with industry or companies, then it's not there's a big chance for the students as well.
And not, like you said,
To
not all supervisors have
yeah, that is true.
those
Yeah.
types of connections. Exactly. So, but so one important thing that I want to, a concept that I want to push in this community is that we can't rely too much on the system, on the academic system, or on the other side, the industry, or the job market. So the concept we are trying to understand here or practice more is more towards, like I said, being less reliant on the systems because they are very like heavy, they have a lot of moving parts. So it's not in our capacity to change the system because the system always pushes back, right?
Yeah.
What can we do as individuals? What can we do as what can I do as a PhD student, PhD graduate, as a person like I'm in my fourth year of PhD, fifth year of PhD, or third year of PhD, and start looking for jobs, start like developing those tools and techniques that can get me a job after graduation, for example. So we're trying to build that concept and that understanding and perception here. So what maybe we can end the conversation with this question. What advice would you give to others who are in similar stage like yourself or PhD candidates who haven't graduated yet?
So if I want to give an advice to a PhD student, I would prefer to give to first to PhD students in their first or second year because I think it's going to
Mm,
benefit them the most because it's already kind of late for a person in the fifth year or a person who's doing postdoc.
mhm,
Uh, uh, Spend some time, in my view, search about the industries that you're interested in and search about the skills that they require.
mhm,
Uh, so I have a very good example in mind. Uh, when I was doing my postdoc, we had this collaboration with Japan, and there were some Japanese PhD students that were coming to our lab to work with us. And one of them, I think at his second year, uh, he got a job. And
mhm,
I told him that this is your second year of PhD. How are you gonna uh, are you gonna get a master's degree? Are you gonna master out and go join the industry? And he said, no, this is common. We find our jobs in the almost the second year of PhD.
mhm,
And then I'll continue my PhD another 2 years or something, then I'll go work for that industry. So then I thought, oh, that's brilliant. It's very good to get your job or at least kind of invest on that, learn a lot of techniques that are going to help you the second year of PhD or third year of PhD. because there are going to be uh, more skills or additional skills that they are not taught in your program, but industry requires them. So I think it's good for students to search them by themselves and gradually learn those things. Uh, so that's one thing. If there are courses that are more towards practical applications, I think it's good if students take those courses. For example, I mentioned this automation and measurement, which helps students to get to work with, to interface computer with machine, and that's gonna benefit them a lot with job seeking in the industry. And I think those are the things that comes to my mind. And the other thing, the third one, I already mentioned, but now that I'm just gonna putting everything together, doing internship, trying to
Gotcha.
convince the supervisor or trying to find a opportunity to do internship so they get to see the companies and industry environment by themselves, to experience it by themselves, not just hear it from others.
Okay, excellent. Thank you very much, Hadi. So is there anything that you would like to mention and I didn't ask?
Uh, no, I think these three things that again I want to emphasize, just taking courses more practical, internship, and just searching for the skills that they can learn that are not available at the universities, for example.
So basically being more proactive
Yeah, yeah,
while working in your
yeah,
own.
yeah, exactly.
Now
Yeah,
that's fantastic advice. So thank you very much, Hadi. I
yeah, my
appreciate your
pleasure.
time. Thank you for being with me in this episode of your genius, your PhD genius.
Yeah, thank you for having me. It was a good experience for me as well.
Thank you. Bye.
Yeah, bye. Bye.